Okay, all right. So today we're going to talk about how to set up for SMAW. This is the machine that you're going to be using, or one of. Um, Half of our welding booths are Miller, the other half are Lincoln. Um, Mr. Clark, which one's the better machine? Well, honestly, guys, both of them are made by the same people. They're all made in China. Um, and the internal components are really all the same. Um, it's just that when they get to a certain part and they've got all the components inside, uh, pretty much the same. One goes this way, and Miller takes and puts a blue box on it and puts a few little touches to it, and the other one goes over here and they put a red box on it, and Lincoln does a few things on it, and they're all pretty much the same. With these machines that we have, I've welded with both of them. They both really weld about the same, honestly. For stick welding, the Lincolns tend to weld a little bit hotter. For wire feed, I tend to like the Millers a little bit better. Just personal preference. Um, I don't know why. I don't like the handle here. This handle on the Lincoln, it tends to get in the way when I'm trying to hook cables up and stuff. But the reason that it's here is it makes it easier to pick up if we're putting it on top of a table or if we're putting it in a truck or something like that. So if you're moving it around quite a bit, yeah, this handle is very nice and easy to have. For our purposes, it's really in the way, other than the fact that it makes a really nice place to hang your electrode holder.
It's not meant for that.
It's really not meant for that. But a lot of times that's what winds up happening is the electrode holder gets stuck there. But other than that, I mean, it's just, and you'll find, especially the way our machines are set up in the booths, this really starts to get in the way when you're trying to hook cables and unhook leads and things like that. It's just a nuisance. And I started to cut them off. We had one machine, we took the cover off and everything, but it's actually tied into the board in here. And so we just left it alone, just left it. So it is what it is. But other than that, they're all pretty much the same machine. Okay. So when you come into your welding booth and you're going to set up for what we call stick or SMAW, shielded metal arc welding, first thing that you want to do is you want to start with your electrode holder. SMAW is welded with a DCEP, direct current electrode positive, and so you have a positive and a negative post here, positive and negative post. And so we're going to make sure that our electrode is plugged into the positive post, and we're going to check our stinger lead or our electrode holder. We're going to check our ceramic coverings here. We're going to make sure that they're snug, they're not loose. I've been noticing several students that I went in to help. It's just a habit that I have when I grab an electrode holder. I'll just kind of feel these, and a lot of times they're loose. Remember that electricity travels on the outside of the wire. On the outside of the wire. If I was to take this ceramic cover off of here, you'll notice that this brass is all bare inside here. That is where your electrical current is traveling. And so if this ceramic protector comes off, your electrical current is traveling just right inside there. And so if that ceramic protector is not there and you grab a hold of it, you're going to start doing a break dance and not to a Michael Jackson beat. It's going to be to about 100 and something volts of electricity that's traveling through you. All right. And it's not that big of a deal. There's actually a Phillips screw that's in there. You just snug it down a little bit to where it's tight again. All right, so you want to make sure that these are snug. You want to make sure that your handle here is snug. And again, there is a hex set screw inside there that if it's loose, you just snug it up to make sure that it's snug. All right. Again, this entire piece inside here, this entire handle, is made out of brass, and so you want to make sure that your handle, your ceramic parts are all intact and not damaged in any way. Make sure that your spring is good and snug. Okay. And then you're going to start checking your cable, your lead. You're going to make sure that it's not kinked. You're going to make sure that there's no bare wires that are exposed. And you're going to make sure that it's plugged into the machine. On the end of your lug, it'll have a little notch on it. And that notch will slide right into the notch right there into the machine. And then you'll just turn it clockwise until it stops, and then just give it a little tug, and then it's secure. Right. So that's how you check the lead on your electrode holder. Then move it over. We're going to do the same thing for our ground. You're going to check and make sure that it's snug. And you're going to check the cable, make sure that it's not kinked. There's no bare exposed wires anywhere. Follow it all the way to the end to where it connects to your work table. You're going to make sure that it's connected to the clamp, whatever type of clamp you have. Make sure that the jaws on the clamp work good. Make sure that on this type of clamp, make sure that your steel braided cable inside here is good. Make sure that this brass jaws are in there snug. And if they're not, again, you've got just a couple little set screws right here. Just snug them up. That's all you got to do. Right. And then once you're sure that your work cable or your ground cable is good, in our welding booth, there's mainly 3 places that you can hook your ground cable to. You can work it directly to the table. I don't like doing that because it tends to get in the way of where I'm working. On the back side of the table, there's a little piece of 1-inch flat bar that's welded. You can hook it to that so that it's underneath and in the back. Or underneath the table, there's a piece of round pipe that slides on and off of the arm. There's an adjustment screw on there that you tighten down to keep the table from rocking. You can hook it right directly to that so it'll kind of hang. That's usually where I hang. That's usually where I hook my cable to. All right. So I'm going to go ahead and hook my ground to my table there. Once you've done that, we're going to turn on the machine. Right here's our on and off button. We're going to turn it on. And while it's turning on, I'm going to have a drink of coffee while it does its magic. And there it goes. This little box right here gives us our welding mode selection. Really, that's all we need to worry about right now. Okay. If we're not sure what mode we're welding in, there's some little icons right here that'll kind of give us a clue as to what mode we're welding in. And you can see the stick, you can see the TIG icon, and you can also see the MIG icon that kind of looks like the MIG gun there, right? There's 2 that's there for stick. There's stick soft and stick crisp. I usually set mine on crisp. I can tell a little bit of a difference, but you probably won't be able to tell, so it really doesn't matter. There's a button right here that's a selector, and it allows you to choose between the 5 modes, and you just go till the light lights up next to the mode that you are welding in. All right? Do not worry about these knobs over here on the side. Those are there to fine-tune things, but for what we're doing, it doesn't really need that much fine-tuning. But this is your output or your amperage selector. Depending on the electrode, depending on the metal, all of that will determine how many amps we're going to be running. Right now I'm using some E6010 that is 1/8 inch. So I'm going to set it I've got it set at about 86, 87, 88, somewhere around there. For what I'm doing on the plate, that tends to run an arc pretty decent. So again, depending on the size of the electrode, the thickness of the metal, that will all determine how many amps you're going to run through your electrode. Okay. Now, as far as setting up for SMAW, that's pretty much it. The other part is going to come in, and I'm going to turn the machine off because I don't want to inadvertently hit an arc while I'm doing some other demonstration here. The other part is going to be hooking up your electrode into your electrode holder. Okay. We notice on our electrode, we have the gray part where the flux is, and also, just sidebar note, we can always tell what electrode we have because right here on what we call the stub, which is the last 2 inches of the electrode, right here on the stub is going to give us an AWS rating number. And it's going to be 6010, 6013, 7018, 7024, whatever. Now, it's not going to tell us the diameter of the electrode. That we're going to have to kind of learn to figure out ourselves. But which is larger, 1/8 inch or 3/32? Yes, 1/8 inch is larger. And once you've looked at them and held them and felt them, it's pretty obvious. Yeah, you can see it. You'll be able to see it. And so it doesn't give you, again, it doesn't give you the diameter size, but it does give you the electrode. So if you're not sure what electrode you're using, just pick it up and take a look at it. This is E6010 right here. All right. So you can always tell what electrode that you're using. Okay. And so here you have the metal part. That is the part that you're going to hook into your electrode. Believe it or not, I've seen students try to hook this to the flux into the electrode holder. Now, well, I don't know why I can't get as far. Okay, well, because you don't have any electrical current. Right. If you notice in the jaws of your electrode holder, there's several different ways that we can hook this in. We can hook it in to weld this way. We can hook it in to weld this way. We could hook it in to weld overhead like this. But we just, and this is the most common way. Even if you've got to weld in the 2G, which is vertical, even if you've got to weld the 3G, a lot of times, even if you've got to weld overhead, this is probably the most common way. Okay. Depending on the position. Now, sometimes this will work, but just depending on where you're at, this works just as good. All right. So this will be the most common way that you will hook your electrode into your electrode holder. All right. When you're striking an arc, there are two different methods for striking an arc, and I'm going to use my two different methods for striking an arc. There's what we call the tap method. I'm over exaggerating for the benefit of the audience. Okay, obviously you're not going to lift it up that high, you'll break arc. Okay, really it's more like this. Okay. That's probably the method that I use the most, right? Especially if I'm trying to restart my arc, because I don't like getting uh, uh, arc burns in the middle of my plate and stuff like that. I tend to use the tap method the most. Then there's the scratch method, which is simply like striking a match, but you guys are too young to know about matches, so you don't know anything about that. So I'm sure. Okay. Yeah. So it's like scratching. Okay, and again, I'm over exaggerating. Again, it's probably more like this. Okay. And then once you establish your arc, then you're going to start with your weld puddle. E6010, E6011, you probably want, well, you want a little movement with it. So once you establish your arc, you're going to start either a stitch motion, what we call a whip and pause, or I like to do little circles. Establish my arc and then start a little circle. Whichever motion you decide to use, you want to keep that weld puddle, or you want to keep your motion no bigger than your electrode. Okay? If you're doing puddles that look like this, okay, you're counterproductive. That's way too big. You're not melding the metal together. If you're doing puddles like this, all you're doing is burning right through it. All right. So you've got, once you strike your arc, you've got to start developing those circles or that stitch motion. And the trick with the stitch motion is you've got to come back and let that puddle burn together again long enough to develop a weld puddle that's big enough to meld the metal together to create that weld puddle. You understand? Does that make sense? Okay. All right. These are a couple that I did yesterday. Just a couple that I ran, and I'm going to do the same thing on the back. All right. Once you've got everything in place, then you want to start talking about our safety equipment. All right. This is your welding helmet. Your welding helmet should be turned off. There's a knob here on the side. You want to turn it on, and you should hear that click. Once it's turned on, you want to set it on 10. Set it on 10. 10 is the shade that we use for SMAW. If we're doing TIG, GTAW, or if we're doing GMAW, we may set it up to 11 or something like that. But most of the time, we're just going to run it at 10. When we're done at the end of the day, let's make sure that we turn it back off. All right. If you put this welding helmet on and you strike an arc and it stays a green and it doesn't go dark, stop immediately. Do not continue to weld. First thing, check and make sure that you turned it on. If it's on and it doesn't turn dark, bring the helmet to me. I'll get you another helmet. I'll check it. I'll get you another helmet. Okay. Do not continue to weld if this helmet does not go dark. All right. These are auto tinting helmets. They should go dark immediately when you strike an arc. All right. If you continue to weld and this helmet does not go dark, you will develop arc burn on your eyes. It's basically getting a sunburn on your eyes, which is not fun. Okay. If you have a lens on here that is all scratched up and it's difficult for you to see, come see me. I'll show you how to change it out. It's not that difficult. Your helmet, and because we only have a short time together, if you're going to make welding your profession and you're going to do this, go spend the money and get you a nice welding cap. Okay? They're not that expensive. You pick them up for less than $5, and it's against the welder's code to wash them. So they get that good funky smell to them. Yeah. Yeah. All right. It's against the welder's code to wash them. All right. And your welder's cap is always worn on the opposite side of the hand you weld with. So if I weld right-handed, so I wear my cap to cover my left ear, because as I'm welding, my sparks are typically going to fly from my right to my left, and so I want to cover this ear to kind of keep sparks and stuff out of this ear and off this side of my neck. Your welding cap, your welding hood, these straps should be adjusted to set down on your head, so that when you put your helmet on, and I'm going to turn around so the camera can see, but it should set down on the base of your neck like so. All right? Because you're going to be, okay? And if you have the adjustment too far up, the first time you flip your helmet up, then your helmet's going to come flying off. All right, so make sure that it fits down to the base of your skull there, so that it holds the way that it should. Okay. Welding gloves. Okay. I tell my students every year, welding gloves are to protect your hands while you're welding. These are welding gloves. These are not carry around hot metal gloves. These are not dip hot metal in the water tank gloves. These are welding gloves. And when you carry hot metal, or if you get these wet, what happens is they get stiff. And what do my students do? They carry around hot metal with them. They get them wet by dipping metal in them, and then they get stiff. And then they go, Mr. Clark, I can't weld with my welding gloves. I said, well, because you used them improperly. That's what we have pliers for. And that doesn't mean you can't use your pliers, with these. All right. But you have to be smart about it. And so, then I get gloves that are like, these, and these aren't too bad. Okay. So that being said, if you find a pair of gloves that have holes that are burnt in them, or they're just so stiff that you can't grab a hold of the electrode holder, you can't weld with them, let me know. Let me know. I'll replace them for you. I have plenty of gloves, and we can get more. Or if you have a pair of welding gloves, welding gauntlet style gloves, that come up to your arms. Don't bring me your lawn and garden little leather gloves, that look like this. These are not welding gloves. All right. But if you got some good gauntlet style welding gloves, you're more than welcome to bring them. But we do have those. Then we have our welding jackets. Okay. You want to put those on. The third line down is going to tell you the size. It says traditional FR cloth, welding jacket, part number, blah, 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 blah. And it'll say SML, 2, and then there'll be 2Xs, 3Xs. Mine has X's that goes all the way here, and then you flip it up, and there's X's that go across the back here and then back down. No, I'm just kidding. All right. Okay. If you get into a booth, and there's enough of us here, just find a jacket that fits you. Find a booth that has a jacket that fits you. Okay. And weld in that booth. All right. Dutch Bros. Better than Starbucks. It is. It is much better. Okay. I like Dutch Bros. Okay. Yeah. When putting on your welding jacket, it's advisable, and it's totally up to you. Okay, it's amazing we call them safety rules, but you know who's to enforce them? I mean, I'm not going to throw you out of my shop, but it's a good idea to button that top button. Here's why. I'm on camera, so I'm not going to do it. But the other day, I'm doing some overhead welding in there, and I was in a hurry, and I just threw this on, and I left this one unbuttoned, and I was making a couple passes, and I had a hot piece of slag. Sure enough, went right down here, right down in my shirt, and I've got I got a second degree burn right there. And it's small. It's not much bigger than my thumb, so it wasn't anything too bad. But I was jumping around for a few minutes. You know, I was like, Clark, you big dummy. Here you are. You're telling students, you're trying to teach them how to do it right, and then you get in a hurry and you go in there and you goof up. Okay, so just go ahead and just button it up. All right, it's or that. Yeah, yeah. So okay, all right. On says me. This welding shield will protect you, will protect your eyes, so it shouldn't blind you too bad. What's that, Tomas? Yeah, they can. Yeah, they can. They see that? All right. So I'm going to show you a couple of ways. First, we're going to do the tap. I'm going to tap, run a little bead, tap, run a little bead. We'll do that a couple times, and then we'll do the scratch. Okay? All right. So here we go. Tap. Okay? Tap. And one more. Tap. Okay? Now the scratch. It's really hard to kind of tell the difference between the two. And scratch. And one more scratch. Oh no, it's stuck. Okay? I did that on purpose. Okay? Whenever your electrode gets stuck, do not sit there and fight it. Okay? Simply unhook from the electrode, let it cool off. Once it's cooled off, break it loose, rehook it into your electrode holder, and start over. Okay? Don't sit there and fight it. If you fight it, you're going to get arc strikes across your weld, and that weakens your weld. That creates incontinuities. All right? All right. Let's scratch it again. Cat scratch Viva. Okay, these that we're doing was a circle motion Here's what the whip and pause looks like, a real quick one. And that is basically your three types of your two types of striking an arc and your two types of weld beads. Okay.